Okay, in this video, we're going to actually graph some trig functions, and I think the easiest way to do that is through IXL. If you want to practice this, notice that the call letters are NVC on IXL if you want to use it to practice. Before we go into the video, I do want to talk about the difference between a sine graph and a cosine graph. Now, starting off with a sine graph, notice that go to 0, the sine of 0 is 0, the sine of 90 is 1, the sine of 180 is 0, the sine of 270 is back to -1, and sine of 360 is 0. So we see here what a sine graph looks like, and then what a cosine graph looks like. We know the cosine of 0 is 1, the cosine of 90 is 0. So we see the difference between the two graphs. Now, the way that we're going to graph these is by using basic transformations. Notice it's asking me to graph cosine of x minus 2. So all we're going to do is take this graph and we're just going to drag it down 2 units. So we're going to drag this middle point. Let me see if I can grab it. And we're just going to drag it down 2 units. And that's going to be my graph. Okay, in this one, it's asking me to take a sine graph, which we know that's the first one because we know the sine is 0, 0. And notice that the plus pi or plus 180 is inside of parentheses with the x. So that means I'm just going to take my graph and I'm going to move it left 180 degrees to negative pi. So moving it left, pi, and therefore that's what my graph will look like. Now there is a possibility you might have 2 different transformations. This is a cosine graph, so we know that's an even function, and that's going to be this one. The 2 transformations, notice what's inside with the x is a minus pi, so I'm going to move it right pi or right 180 degrees. The minus 2 is on the outside, so I'm going to move it down 2. So I'm going to click the middle of my graph here, and I'm going to drag it right pi units. I'm going to move it down 2 units, and that's what my graph will look like. Okay, let's move on to a little bit more difficult ones. Again, you notice this is a cosine graph again, but look what's out front. You have a negative and a 4. We know that negatives flip graphs. We know that multiplication and division stretches and compresses graphs. If it's inside with the x, it's going to stretch and compress and flip horizontally. If it's outside where it's located here, it's going to stretch, compress, or flip vertically. So notice you've got a negative and a 4. So what I'm going to do is I'm going to take the point that was up here at +1, and it's going to get flipped over to -1. And it's going to get stretched 4 times, so it's actually going to get flipped down to -4. So let me go ahead and flip and stretch that graph. Now it's pretty easy from here on out because now we're just following the same transformations as before. Because the minus pi inside with the x is going to move it right 180, and the plus 2 is going to move it up 2 units. So let's go ahead and move it right 180. Let's move it up 2 units, and that should be my graph. Okay, this next one's a little tricky, and I'll show you why in just a second. But it is a sine graph, so let's go back to our sine of 0, 0. This one has been stretched times 2 and flipped. So therefore, what used to be up here at 1 is I'm going to pull down here if I can. Let's try that again. What used to be at 1, I'm going to pull down here to -2. And the other transformations, here's what makes it tricky, is inside where that 3 pi is located. We're going to move it left 3 pi. Well, moving it left 2 pi or 360 is going to give the same graph, so I don't actually have to do that. I can just simply move it left a single pi, and it's going to be exactly what it was before. We're going to move it down 1 unit, and that's what our graph's going to look like. Okay, let's work one last problem. And again, this is a cosine graph. I'll go ahead and warn you that the way you have to do this on Desmos, on IXL, is kind of tough to understand. But first off, we're going to focus on that x over 2, which first thing that I need you to understand that x over 2 is the exact same thing as 1/2 x. And if you have 1/2 x, it's not being compressed by 1/2, but it's actually stretched twice as wide as what it used to be. So I want you to look in at the graph with me. And the point that's at pi over 2, or 90 degrees, notice it's at 0. It's 3 boxes over. That dot, in order to use that, in order to perform that transformation, that dot has to be now 6 boxes over. The dot that is at 0, 1, if you stretch that twice as wide, it remains at 0, 1. When you multiply 0 times anything, it's going to stay 0. So the way that I actually stretch this on IXL is I'm going to pull this pi over 2 dot over to pi, and I'm going to pull that top dot back to 0 where it was before. Again, the pi over 2 dot, which was 3 boxes over, is now 6 boxes over. What used to be at 0, 1 is now still at 0, 1, and this graph is twice as wide as it used to be. Now the next thing, the 3 out front, you always perform stretches, compressions, and flips first before you do any of the plus and minuses. So we're going to make this thing 3 times taller. So what used to be at 0, 1 is now at 0, 3. And the last thing is we got to move it up 5 units. So I'm going to grab the middle right here, move it up 5 units to right there. I believe that's right, and that should be the correct answer.